Picture this. You finish your GCSEs at 16, ready for the next steps of growing up and becoming an adult over the next few years, and then you get your letter of acceptance to your first choice of college, a magic school, where you want to go to learn the true nature and wonders of our reality, harness the powers of chaos, bend the elements, heal and protect yourself, your community, and the lands you live on. But then you get to this school, and while it does resemble the schools you know and love from fantasy and fiction, you're actually surprised to find out that half your classes are just crafting and practical skills akin to a modern apprenticeship training program, while the other half are maths, science, and history lessons. Utterly disappointed, you wish you'd paid more attention during your GCSEs when images of triangles, stars, and circles are put up on the chalkboards of the lecture theatres and make absolutely no sense to you. What does sine, cosine, and tangent have to do with magic? When do you get to throw firebolts or magic missiles at something? Well, let me tell you, let's talk about it. Welcome back to GCSE Minecraft and Chill, where I chat about whatever interests me about GCSE maths and science topics while playing Minecraft to entertain myself and maybe you. I hope your day's gone well so far and that you've got yourself a drink and something to do while we revise trigonometry with a magic lesson. So while nobody is throwing firebolts or magic missiles from the palms of their hands in our shared reality, the discipline, study, and practical skills associated with the arcana of our universe is actually a very real world of usually self-study, a ton of reading, and communal rituals, gatherings, and events that have profound impacts on the world around us. So today we're going to talk about why a basic education in trigonometry might be one of the first steps in the journey to become a proficient person in chaos magic, enchantment, and manifestation. Now, to understand why trigonometry is important, one has to understand why circles, triangles, and squares are important. That, and because trig is just part of geometry, is why this is sort of like a sacred geometry part 2 video, so if you didn't catch that, consider checking it out because some of the later stuff in this video is going to make a lot more sense if you've watched it. But if you've ever asked me what my favourite part of maths is, and let's be honest, why would you ever? But if you did, my answer would easily, far and above all the rest, be trigonometry, if not geometry. So this video is sort of like my silly video, my love letter to trigonometry video. And I know it seems kind of boring and confusing and utterly unrelated to your everyday life, but that actually couldn't be farther from the truth. I think it's one of the most applicable subjects that you learn about in maths. Well, I actually kind of think I say that about all of the maths topics, but that's because I believe that maths generally is very applicable to everyday life. But listen, okay, I say that about trig because while at school you tend to focus on the Pythagorean theorem and right angle triangles, applications of trigonometry go so far beyond that. So we will talk about those kinds of triangles a little bit, but I kind of want to broaden your perspective on what trigonometry is and what it means. And despite not liking maths all too much at school, or at least before I did my A-levels, I still managed to find joy in trigonometry. Triangles are just good shapes to me, if you know what I mean by that. Something about the nature of angles and measurements and the relationships between sine, cosine, and tangent with geometry mixed in. It just clicked in my brain, even though it felt impossible to put into words exactly why that is. There's just something about it, a quality that it possesses, that when you actually piece it together and understand where the functions are coming from, you're like, ah, yes, perfectly natural. Of course, that's how the universe works. And it's kind of like when you get to grips with what pi is. Pi is such an esoteric number. If you've ever asked yourself, why is pi? Then you kind of know the line of thinking that I'm talking about here. And you're probably a little bit of a magician. Or an even simpler question, why are corners? Seriously, ask yourself right now, why are corners? Before you say, what on earth is this person on about? Imagine a little kid came up to you and said, why does a corner look like that? And pointed at the spaces above or below a door frame, the ceiling, the floor, you know, where our three-dimensional space connects in 3 directions at 90 degrees each. What would you say to them? Because for me, my brain goes to, well, when you connect flat surfaces and you need that surface to be solid, stable, supported, it has to connect orthogonally, which means at 90 degrees, like the vertices of a square, a good, solid, stable shape, it will stand up by itself. And we make our bricks like that, and we flatten the surfaces of our bricks, pop a flat ceiling over our heads, have a flat floor, and boom, you have a 3-dimensional corner. But that doesn't actually answer the question, does it? The kid might then say, why, over and over again, and you'll get locked in this. And you'll kind of end up realizing that you're just describing the original observation again with more and more complicated words. Why actually are corners the most stable structure for our floors, walls, and ceilings to intersect? What is so special about 90 degrees, or so-called right angles, that makes them so right? Why are so many maths, physics, and mechanics concepts simplified once there's a 90 degrees involved? Well, think about a straight line. Let's start there. When we measure that, we call it 180 degrees, half of a full turn. Since a full turn is 360 degrees, so a straight line is just half of that. If you're going forwards and backwards, you're still moving on the same axis, the same direction. So like if I go north in Minecraft, the opposite going in a straight line would be to head south, but I'm still on the same north-south axis. To go a completely different direction, the most different direction I could possibly go in, would be the exact halfway turning point. Otherwise, I'm still sort of on this north-south axis direction. So the halfway point would actually be the east-west axis, which of course is at 90 degrees. So a right angle represents the most different direction you can get when considering a motion or a direction in three-dimensional space. And the consequences, implications, ramifications of that are huge. They're mind-blowing. Just from that one example, you can start to imagine why other specific angles might be important or special. Like half of 90 degrees, 45 degrees. That gives us the right-angled isosceles triangle, the second most stable supporting structure of them all, the most stable being the equilateral triangle, 60 degrees, hence why vertical structures often have right-angle isosceles triangle supports. So there's just certain angles that make sense in mechanics and physics and nature. Now, that might get you thinking about and connecting how circles, squares, and triangles are related to each other when we're considering angles and measures. And this is even more so when we consider a 2D grid or a set of axes for determining directions of motion in a 3D world. And this is actually a really good foundation for getting to the bottom of trig. But you usually start in classes with constructions and angles, more generally speaking. And I love construction because so long as you have a fixed point, usually a pair of compasses, but it can be just as basic as a stick stuck in the ground with rope attached or something heavy, and you can accurately construct pretty much any regular angle you need. You need to know how to construct triangles and perpendicular bisectors to grasp the basics, and then you move on to angle bisectors and perpendicular lines from a point to a line. And there are some awesome tools on the internet to help you practice this, but the best way is to really grab a sharp pencil, get a protractor, a ruler, a pair of compasses, and practice yourself. I'll link below to the tool I'm using on the screen right now to demonstrate these. They're so simple, but memorizing all of the steps can be a pain if you don't really get them or get why they work. And I always found it incredibly frustrating at school to be taught something that was true and not taught why it was true. Like the corner question, like I would want to know why actually I hadn't considered that before. Why are corners? Why is pi? And that's why I like to learn maths from first principles. I think it's really helpful. But proofs of things we take for granted like that can actually get quite complicated quite quickly. But for anything to do with angles, the secret ingredient in all of these tricks, processes, equations, it usually comes down to some property of a circle. Now, circles are absolutely amazing. They've been worshipped by humankind since forever, mystical, magical things that they are. Or if they haven't been worshipped directly, the image of them has been used to be associated with the divine. The celestial bodies that drive our existence in the sky, our own, Earth, approximately spherical, and source of endless geometric truths and possibilities all start with a circle. So if you really, really want to understand trigonometry, understand why constructions work. Unfortunately, explaining the proofs and explaining all of it in detail is a bit beyond the scope of this video, but if you want me to get into it, I can do another one where I will get into it. But here's a clue. Think about why the compass point and the pencil have to stay the same fixed distance apart for pretty much all constructions for at least a couple of steps. What is it about that distance that forms the arc, the curve, to create these exact constructions? Well, if you hadn't guessed, spoiler alert, it's because circles. Right, we understand that a circle represents the line a fixed distance away from a central point for a full rotation, which we said is 360 degrees. Now, that fact alone and everything that goes into that could be an entire tangent itself, pun intended, because it comes from the ancient Babylonians and the connection between our use and observation of circles and patterns of motion and measurement from the sky, from an earthly year, from stars moving, and we just used it to make something that we could easily divide into lots of factors, especially multiples of 3, since that's so important for triangles and all of the forms of measure. Now, scholars throughout history have been preoccupied with the measurements and observation of the stars and planetary movements, as well as with land, architectural, engineering, measurement questions, all of which require knowledge of circles and trigonometry, as well as scholarly works from Babylon, Sumeria, and Egypt. The Indian mathematician Aryabhata is credited as the origin of the sine function in his monumental astronomical mathematical writing in the 5th century, or if not the origin of the function itself, at least one of the first major writings. And I love reading these old works and seeing how maths really hasn't changed that much for hundreds of years, yet the way that we apply it is so incredibly broad now compared to how we used to use it. as well as in engineering, architecture, astrophysics, mechanics, abstract mathematical and geological applications of trigonometry. All are super interesting to me. For example, one of my favorite examples to talk about is how geologists can estimate the thickness of a bed of sedimentary rock, provided you can see and measure the distance between the contacts with the beds above and below it, measure the strike, which is the direction, and the dip, the slope of the bed in the outcrop, relative to the horizontal. This gives you all sorts of other cool information, not just the thickness of the bed. Very cool. Or we could talk about navigation, another great example. When you're at sea and you've only got the stars or in the air, these disciplines all require understanding bearings, changes in direction, and circles and triangles over all sorts of grids in 2D, 3D, and 4D. Very advanced trigonometry. Of course, we have computers handling most of the calculations, but you still need to understand what's going on. You still need to know your stuff. And of course, one of the hugest examples is waves. Waves and vibrations, especially those in nature, they all tend to be sinusoidal in form. And by that I mean that they oscillate up and down between a maximum and minimum value, and they repeat periodically. And lots of them tend to have the waveform abide by some transformation of the sine function. So this leads on to all sorts of interesting fields of study, analysing electronic data, interpreting signals and patterns in natural phenomena, from particle physics to crystallography to seismic waves to extragalactic electromagnetic waves. Even our breath, the flow of our life and energy in and out of our body, goes up and down regularly, periodically, between a maximum and a minimum, following in cycles upon cycles upon cycles. So there is literally no part of nature that isn't affected by or related to trigonometry. Now, I keep talking about sine, cosine, and tangent, and I haven't actually defined them yet, so I'm just going to quickly do that. Hopefully, over the next week or two, I'm going to be putting out some shorts specifically dedicated to revising them, so check back in for those. But just briefly here, they are functions, meaning we put in an input value and we get an output, and for these functions, we have to input an angle value and we get an output that tells us the ratio of two lengths. Those lengths are the different sides of a triangle relative to the angle you're looking at, and you use a different function depending on which sides of the triangle you're looking at. So in a right angle triangle, sine will tell you the ratio of the opposite side's length to the hypotenuse's length, cosine will tell you the ratio of the adjacent side's length to the hypotenuse's length, and tangent will tell you the ratio of the opposite to the adjacent lengths. And you might have heard of the sine and cosine rules, which will tell you how to find angles or side lengths in non-right angle triangles too. This concept connects to the circle through a very useful tool called the unit circle. This is when we set the radius as 1 and we center our circle on a Cartesian grid. So again, we're connecting circles to the griddy nature of our reality, where the x-axis of the graph is going to be the angle we have rotated around our circle, and the y-coordinate is going to be the vertical distance away from the diameter. I'll throw up a diagram so you can see what I mean. This is a little bit complicated. We have one grid centering our circle, just measuring a distance, and we have a second graph showing us the angle and the vertical distance. Now, just think of all angles, right? All angles are just a way of communicating what portion of a full rotation you've moved through in order to change a direction. When you connect that change in direction with the shortest, straightest distance between where you started and then where you changed, you have a triangle. So when we're using the coordinate axes to plot the changes in vertical distances as we move through a full rotation, we see something cool. Consider what happens at 0. Flat on the x-axis, we have no vertical distance. So if we wanted to measure the vertical height of the circle's edge from the x-axis, there isn't any. It's 0. So the graph starts at 0. Now, going anti-clockwise towards the y-axis, let's see what happens at a quarter turn. 90 degrees. We're now at the full height, the maximum radius of the circle. Now, if we keep going again another half turn, we get back to 0, and then a 3/4 turn, we're back at the maximum height of the radius, but in the negative, and then back to 0. So you see this cyclic, periodic, up to maximum, back to 0, up to maximum, back to 0. Now look at the graph that we've just plotted. That's a sine wave. This hugely important and relevant graph that comes up in science and nature everywhere arises just from considering the lengths of the sides in a triangle when you plot them inside a circle on a coordinate grid. What in the world? Maths is really cool. At least I think so. And I wanted to show you this really cool website that shows really clearly what happens when you do this, when you move around the circle like this and track the y-coordinate. You see this sine curve emerges because that vertical height is the length opposite to the angle we're moving through on the x-axis. And remember that sine connects the opposite sides of a triangle to the hypotenuse, which is the radius of the circle. Then the cosine graph, that's going to track the adjacent side. So we're seeing the horizontal length, which is like the y-axis but rotated 90 degrees. So the cosine curve is going to follow the sine curve but a quarter rotation behind it. Sine and cosine complement each other, each being 90 degrees apart. Sort of like how the two angles in a right angle triangle add up to 90 to complete the triangle. One length is going to be the the sine ratio, whereas the other will be the cosine ratio, and vice versa for the other angle. Now, the tangent curve is where it gets a bit weird. A tangent is the ratio of the two lengths. The hypotenuse isn't included, so it becomes like an inverse gradient of this graph. Tangent ends up looking really weird because you're either dividing by themselves to get 1, or you can be dividing by 0, which gets infinity, which is why we end up getting this asymptote, or some fraction or ratio between the lengths, which can either mean we're really small or really, really big. So that is how we've come full circle, pun intended, understanding how trig relates to circles, how circles relate to grids, and how triangles connect them. So how will this understanding improve your magic as a beginner at magic school? Well, we're going to start right at the beginning. You start with understanding circles, as you might have gathered from my preamble, or should I say my pre-ramble, and so I'm just going to talk about a little bit of the spiritual implications of a circle. All of our universe, our shared reality, and potentially the metaphysical realms beyond our perception revolve in circles, contain circles, operate in cycles, and take material form in spheres and rotations. We see this with atoms, with orbits of electrons, planets, moons, stars, and their endless celestial and arcane rotations. Vibrations of matter and energy fluctuate sinusoidally. As I said in my geometry video, the universe seems to be formed of these fundamental building blocks of regular solids and polygons, and these shapes and forms are favoured for their symmetry, which is, I'll talk about that in another video, and because of their consequences on the density and aerodynamic matter of nature, which I will also talk about in my next physics video, but I will talk about it a little bit here. Very, very simply put, the circle is the most regular form with the minimum surface area to volume ratio. It's very easy to put together and collapse mass and matter through gravity, and it becomes a spherical blob. That's how planets and moons happen, and think about suspended water droplets floating in space. They form little spheres when there's no air resistance turning them into a perfect rain droplet, because that sphere minimizes the energy required to maintain that surface tension of the water blob so it doesn't just collapse and splash. When gravity or other forces external to that blob are applied, they do deform slightly, but left to their own internal forces and devices, they're perfect little spheres, which down on the ground to us, when we're looking at moons, stars, planets, looks like circles in the sky because we're seeing a 2D view, right? So in other words, and sort of more magically speaking, circles contain stuff. They surround stuff, they collapse things into the smallest space possible, requiring the minimum amount of energy to do so. Using this property in magic connects to why we use circles for summoning, for binding, for connecting and channeling energies, and why a spell or a sigil will be usually contained within a circle. It is a protective minimum energy boundary between whatever we want happening inside the circle versus outside of it, and this is either a natural consequence or an intentional thing that someone can craft. And we have significant symbols that are just themselves circles that represent potent magical and metaphysical energies. Like I already said, the sun and the moon, Earth itself, the rotating spheres of the cosmos, all taken as 2D slice views, are circles. Within a circle of a community gathering, there are infinite places to have everyone join in and contribute their energies into the center of the circle. Within a circle, a witch casts to protect and contain the energies within a ritual. Any shapes within a circle can carry different meanings or energies either into the space or from the universe. And if you're outside on the floor and all you have is sticks, chalk, water and powders, all you need is a bit of rope, and you can construct your sigils accurately without the need for a giant protractor or giant set squares and pairs of compasses. That would be silly. But the same is also true if you're crafting a tiny little talisman or inscribing a protective enchantment in runes or sigils onto a charm on paper, but also leather, fabric, stone, wood, metal, any material, be it clothing for decorative purposes, a tool, a weapon, or a gift. You won't necessarily have tools that are the appropriate size or shape to give you accurate angles that you need for a particular sigil or charm. So knowing the basics of a few construction can massively simplify and enhance the efficiency of this process, especially if you're repeating it over and over. You don't want to have to worry about measuring every single angle accurately every single time. Now, wanting the shapes to be regular and accurate can be really important for ritual purposes, especially if someone is a ritual caster, channeler, charmer, or enchanter, and they require the steps to be followed just right to appropriately channel and focus the required energies for their spellcraft. Just like a chemist or an alchemist mixing some concoction needs to follow a recipe and add the ingredients in the exact right ratios, carry out the steps for the correct length of time, or else risk ending up having a product at the end that isn't at all what they wanted. For certain forms of spellcraft, having accurate designs and precise ritual steps is an important part of the meditative, devoted art and practice to channel energies and focus on the subconscious through the conscious mind. Of course, not all practitioners do things that way or believe that that is necessary, and it certainly isn't for all forms of magic. It's all about what works for the individual and what you're trying to achieve. But since magic is often about creating a certain state of mind to bring forth the creative potential energies of the subconscious, primal, or intimate parts of our instinctive and expressive selves, following a prescribed set of accurate steps in a ritualistic fashion can help create the calm, as well as, many believe, being required to allow certain energies within the universe, not just within ourselves, to flow properly for the ritual and for the purposes of the ritual. Like how you can create a narrow, concave channel and it becomes a wind tunnel, drawing air rushing down through the gap, as often happens between buildings and built up areas. So too do some magicians believe that the correct images, shapes, angles, and proportions allow a certain energy or vibration to channel through them through the universe around us. So that is why some specifically created sigils have this precise trigonometric construction and the use of right angles, triangles, and curves, and they sometimes end up being referred to as keys because they are perceived to unlock certain aspects of the heavens of divinity or divine power, because they allow their energy to channel through, as well as being symbolic images of certain powers, mysteries, or divine characters, or even things like angels and demons. And in my geometry video, I spoke about some of the symbols that utilize certain regular polygons, as well as stars, shapes, and symmetries to represent aspects of metaphysical existence, divine ascension, or deep alchemical inner workings of the soul or of life itself. These images, symbols, sigils, stars, squares, triangles, often inscribed within circles, have just absolutely become ubiquitous in magical imagery in real magical communities as well as in fiction. Glyphs, or ancient sigils and seals and marks of power, all seem to have this geometric, trigonometrically precise construction. Like, think about Doctor Strange's sigils, or runes in Skyrim. Full Metal Alchemist uses this heavily. There's even one in Hell's Moving Castle, multiple. And even Doctor Who utilised this concept. There's so many of them that there's a whole list of them on TV tropes. So it seems to be universally acknowledged that within science, arts, crafts, and modern magic, that there is power in accurate angles and regular shapes, especially if you inscribe them within a circle, as something about simple polygons that connects our natural material world to the architecture of the universe and beyond into the metaphysical. To me, that makes it worth studying and appreciating. I would be curious to know which is your favourite of the regular polygons, why that shape seems to appeal to you, and if you were to craft a sigil for yourself for success in maths, what shapes and structures would you use? What materials do you think would work best? For me, it has to be the pentagon or the pentagram, the heptagon or the heptagram, and equilateral triangles, combined with metal or good old chalk on stone, or putting pen to paper and crafting a sigil with ink, and then possibly burning it in a burning bowl and keeping the ashy remains in a little spell jar, or whatever other actions would be safe, appropriate, and harmless to the environment that you would choose. So let me know, and I would also love to know if there is some aspect of our mathematical reality that resonates with you as you've listened to this today, something about waves, shapes, angles, or circles that just has that feeling of rightness or correctness to you. Let me know about it, because I'd be very interested to know if I am alone in this feeling. Because for me, the characteristic wiggles of the sine and cosine waves are just so utterly natural and magical, and I can't quite articulate why they feel correct to me, as do constructions generally. And I don't even know the proofs for all of them, but I can still appreciate and resonate with the process and the result. So I highly recommend you check the tutorial below and construct your own regular pentagon inscribed in a circle on the construction tool that I used. But anyway, thank you for watching all the way to the end, and if this chatty revision session made you appreciate trigonometry just a tiny bit more than my work here has done, don't forget that our words are spells, so be extra kind to yourself, especially as exams approach. Have a lovely rest of your day, and I will see you next time. Yalla bye.